Hi, this section is about simplifying complex fractions. A complex fraction is an expression with a rational expression within another rational expression. So here are a few examples. So if you look at this one, this entire thing is considered to be the complex fraction, but I have a rational expression in the numerator and another one in the denominator. Here again, I have another rational expression. Here I have a numerator that's just two terms, but my denominator is a rational expression. So you can have both numerator and denominator with a rational expression, or it could just be in one of the positions. And then finally, the last one has the entire thing is the rational expression, but I have multiple rational expressions within the overall rational expression. All right, so how do we simplify these? So there'll be a few steps that you're going to want to take. First, you want to identify the LCD of all of the denominators in the complex fraction. Then you're going to multiply the numerator and the denominator of the complex fraction by the LCD. And what this will do, it will cancel the denominators. It should always look simpler or less busy than how you started after doing this step. And then your last step is to simplify if possible. Remember, rational expressions are like fractions. You always want to leave them in simplest form. So if it has any common factors in the numerator and the denominator, you're going to want to cancel them. All right, so here are a few examples. I want to simplify this rational expression. I have just a monomial in the numerator, and I have these two terms in the denominator, and the 2 over x is my rational expression within this complex fraction. All right, so my LCD, if I'm looking at the denominators, well, I only have x as a denominator, so my LCD is x. So as I mentioned above, the next step is to multiply the entire numerator and the denominator by x. So remember, multiplying the top and the bottom by the same expression is the same as multiplying by 1. That means you're not changing the value of the expression, you're just manipulating it so that we can simplify. So always multiply numerator and denominator of a fraction by the same expression. Okay, so when I multiply, 8x times x gives me 8x squared. But when I multiply the denominator, well, 2 times x, that gives me 2x. But when I multiply x times 2 over x, the x's will cancel. So I just have 2. So my fraction, my rational expression, is no longer a complex fraction. It is now this rational expression, 8x squared over 2x minus 2. Now, this is something you can simplify because the denominator can be factored, and it factors into 2 times x minus 1. And once you do that, you see that the 2 goes into the 8 4 times. So your final answer is 4x squared over x minus 1. Okay, let's try another one. This has a lot more going on. I have multiple rational expressions in the numerator and one in the denominator for this overall complex fraction. If you look at all the denominators, I have x and x squared and x squared. The LCD is the variable they have in common raised to the highest exponent. So your LCD is x squared, which is what you see here. We use that in order to cancel those denominators. So not to get a common denominator, it is used to cancel them. So you multiply the entire expression on top by x squared and the entire expression on the bottom by x squared. Again, x squared over x squared is just equal to 1. When you distribute, because you will be distributing x squared across all 3 terms, and here across both terms, the first term turns into x squared in the numerator. The second one, 1 over x, so I'll do that over here, 1 over x times x squared. That x will cancel with one of these, leaving you with just x, which is what you see here. And then you have to multiply the x squared by minus 6 over x squared times x squared, Well, that means the x squareds cancel completely, so you get just 6. So my numerator actually looks much better. It's just x squared minus x minus 6. You do the same thing in the denominator. Distribute x squared to 1 and you get x squared. Distribute x squared to negative 9 over x squared. Again, the x squareds will cancel and you just get x squared minus 9. So now you're just dealing with this rational expression on this line, which then has to be factored. So to factor the numerator, you're looking for two numbers that multiply together to give you negative 6, but when you add them, you get negative 1. So that means the signs must be different, which means you are actually subtracting. So the numbers that will work are negative 3 and positive 2. Then the denominator, well, that's just the difference of perfect squares. So that's x plus 3 and x minus 3. Well, the x minus 3's will cancel, so your final answer is just x plus 2 over x plus 3. Okay, we'll do one more. Here I have m plus 1 over m minus 2 divided by 1 plus 1 over m minus 2. Here I have just a denominator of m minus 2 in both the numerator and denominator of the overall complex fraction. Therefore, that's my LCD. So the next step is to multiply the entire numerator by m minus 2 and the entire denominator by m minus 2, which means you have to distribute m minus 2 across. So when I do, m minus 2 times m, that's what you see here, and I'll multiply that on the next line, and m minus 2 times 1 over m minus 2, well, the m minus 2 will cancel and you just get 1. So your numerator no longer has a fraction in it. It's just m times m minus 2 plus 1. Do the same thing in the denominator. Distribute m minus 2 across. So 1 times m minus 2 gives you m minus 2. And 1 over m minus 2 times m minus 2, well, again, those will cancel and you just get 1. Okay, so the next step is to simplify numerator and denominator. In the numerator, you distribute. So I get m squared minus 2m plus 1. In the denominator, you combine like terms. So you get m minus 1. So there's one more thing to do. The numerator factors. It's actually a perfect square trinomial. So two numbers that multiply together to give you positive 1, but when you add them, you get negative 2, is m minus 1 and m minus 1. That means that one of the m minus 1's will cancel with the one in the denominator, so you're just left with a final answer of m minus 1. Okay, so that's it for this lesson. Give the homework a try. Good luck.